Hi, my name is Shane Krahowski, and this is my presentation on space telescopes. So first of all, what is a space telescope? A space telescope orbits around the Earth where it can observe objects in space free of the blurring effects of the Earth's atmosphere. For a space telescope to work, it needs two mirrors, a primary and secondary mirror. The much larger primary mirror will reflect light onto the much smaller secondary mirror, which in return will focus all of the light onto a focal point. The focal point is typically a camera or spectrograph. This allows for a very high quality imaging of objects in space. To show the basics of a space telescope, I did a small simulation in a laser and mirror simulation website. So to represent the object in space, I used a point source. We'll say it's a star that's reflecting points of light, which is represented by rays. These are the primary mirrors that I used. More likely than not, in a space telescope, they would be very close together, and the small point or the small area between them would be where the focal point is, which is a camera spectrograph. And for the secondary mirror, I used a circular mirror, and this is obviously not to scale. I had trouble lining up the rays. And obviously, in a real space telescope, this would all be exact, and the two rays that come off the primary mirrors would most likely become one, which is where the focal point is. I use that blocker to take the focal point, which is a spectrograph and or a camera. So one of the most famous space telescopes is the Hubble telescope. The Hubble telescope is by far the most famous space telescope. The idea for the Hubble was conceived in the 1940s. Followed by decades of planning production, in 1990 the Hubble was launched into Earth's low orbit aboard the Space Shuttle Discovery. However, for 3 years there was a flaw with the imaging which produced less sharpness until it was fixed. The Hubble's primary mirror is an astounding 7.87 feet wide. The telescope itself is 43.5 feet long, and it weighs an astonishing 24.5 thousand pounds. The Hubble is made to detect three different kinds of light: visible, ultraviolet, and infrared. In fact, the Hubble has received light from the furthest star ever detected by NASA, which is 12.9 billion light years away. This star is Earendel. Earendel, which means morning star in Old English, is a star that the Hubble telescope detected at a record 12.9 billion light years away. Earendel has a red shift, or shift of light towards the red part of the spectrum, of 6.2, which beats the record of the previous furthest star, which had a red shift of 1.5. If Earendel is a single star rather than a cluster, astronomers estimate that it is around 50 times the size of the Sun in our solar system. The James Webb Telescope is an infrared detecting telescope that was launched December 25, 2021 from the French Guiana aboard the Ariane 5. The James Webb Space Telescope is the largest and most powerful ever built, about 72.19 feet long. It took about 30 days and 1 million miles for the telescope to reach its permanent observatory spot, L2. L2 is a gravity-free zone that will allow the James Webb to stay in line with the Earth as it orbits around the Sun. NASA has four main objectives for the James Webb Telescope: first light in the universe, assembly of galaxies in the Earth's universe, birth of stars in protoplanetary systems, and planets. Like its predecessor, the Hubble, NASA plans to use the James Webb Telescope to continue to take pictures of objects in space. Thanks for watching, and this is my works cited.